So today we're going to be treating strength of material, pure introduction to the strength of materials. Strength of material is a course for engineering students, also known as mechanics of solid. Now we are going to introduce this course here today. So we'll start by defining the term strength of materials. What then is strength of materials? Strength of material is the ability for a material to withstand forces generated from external loads. Now take note, once those loads are acted upon the material, it deforms. Excessive deformations leads to the structure to fail, which is failure in structure. For example, now let's have a beam. Let's call this point A and point B. This is a beam. Now, when an external load or force, or also stress or moment, any external influence is external. So let's take note that let's call this an external load. So an external load is acted upon this beam. Strength of material is telling you that the ability of this material to withstand this load or external force or stress, the ability to withstand this. Of course, this load is generated from the external force. The ability to withstand this is strength of material. Now, I told you that if this external load is being acted upon the material, it deforms. Excessive deformation can lead to breakage or failure of the material. That is strength of material. Okay, now we're going to define the term called stress. What is stress? Stress is defined as the force per unit area, the force per unit area to deformation. Now take note, stress is defined, this is defined as the force, which is P, per unit area to deformation. Now, let's use this beam to explain what stress is. Now, this is the force acting on this beam and the area of that force acting. So now, mathematically, take note that the stress is symbol is this symbol. This signifies the symbol for stress. So stress is given by this symbol. So mathematically, we can say that the stress is equal to the force, which is in this case it's something as a P or the load, P over the area here. So mathematically, you can say that stress is the load all over the area. The area is this area of deformation or the area at which the load act on it. You can also define stress as the force acting per unit area, or you can also define it as the force per unit area to deformation. So now take note that the unit for force for stress can be gotten from dimensional analysis. Now let's analyze these units and these parameters. Now we know that force is also measured in what? Newton. Area is measured in what? Meter square. So therefore we can say that the unit for stress is Newton per meter square. Now there's something very important you should take note of. Very, very important. Take note that Newton per meter square is the same as what? Pascal. So there's another dimension which is Pascal you can use to represent stress. Also take note of this. In strength of material is very, very important to take note of this I'm going to say now. 1 Newton per meter square is equal to what? 1 Pascal. Very, very important. Very, very important. Also take note that 1 kilo Newton per meter square is, of course, we know kilo. Kilo is 10 raised to the power 3. Is the same as 10 raised to the power 3 Newton per meter square. Also, 10 raised to the power 3 Pascal. Very, very, very important. Very, very, very important. Also take note of this, that 1 mega Newton per meter square is the same as 10 raised to the power 6 Newton per meter square. Also, it is 10 raised to the power 0 Newton per millimeter square. Now, anything 10 raised to the power 0, anything raised to the power 0 is 1. So we can quietly leave this as 1. Now, let me explain this scenario where we have a case like this. Take note that millimeter is 10 raised to the power negative 3 meters. So if we square this, we have millimeter square is the same thing as 10 raised to the power negative 3 meters all square. Now this can be 10 raised to the power negative 6 meter square. So therefore, in a case where we have this, so 1 Newton millimeter square is the same thing as 1 Newton over 10 raised to the power negative 6 millimeter or negative 6 meters. So when we bring this thing up, we're going to have 10 raised to the power negative 6. It's going to be 10 raised to the power 0 negative 6 Newton meter. So this is square, take note. So this is square. So negative is going to give us 10 raised to the power positive 6 Newton meter square. Very, very, very important. Now in engineering, we like playing with our units and powers or indexes. So it's very, very important you know those index, because I can give you a question in where the stress is in kilonewton and it says you calculate the force. I can give you a question where the area is in millimeter square and the says you calculate the stress. You know that the unit for stress is Newton meter square. So you do this conversion. It's very important you play with this in engineering. You play with this a lot in engineering. Now, I've seen a case where people go into exams and they get the procedure, but they don't get the conversion. In a case like this, if you're given a question, use 3 minutes to calm your nerve down. The next thing is to look at the parameters, if they're in the right units, before you begin your calculations. It is very, very important. So now, take note that 1 giga Newton per meter square is the same as 10 raised to the power 9 Newton per meter square. Now, if we are to express this in terms of millimeter square, it's going to be 10 raised to the power 3 Newton per millimeter square. Very, very important. Now we're going to define another term known as strain. We're going to define the term called strain. Of course, it's very, very important you know what strain is. So strain is the deformation or elongation or extension a unit length. So now take note. This is the deformation elongation extension per unit length. So mathematically, for strain is, so this is the symbol for strain. So mathematically, strain is the deformation. So take note, the deformation, the extension and elongation is given by this. It's more of like a change in L, but it's of this symbol. So it is this symbol, of course, which is known as deformation, elongation, and extension per the unit length. So this is the length. So we have the extension over the length. That's what strain is. Now take note, this extension is given by L naught minus L all over L. It's very, very important. You know that this is the unit. When it comes to elongation or extension or deformation, is the new length minus the former length. Very, very, very important. Now, what is the unit for strain? Take note, from dimensional analysis, you're having meters over meter. This will cancel this. So therefore, strain is dimensionless. Very, very important. Is a dimensionless quantity. Very, very, very important. So we have defined what stress is. We have defined what strain is. We have given you what the formulas are. It's very, very important you take note of that. Now we'll go to the types of stresses. Types of stresses. So we have types of stresses. Types of stresses. Now, number one, we have tensile stress. Tensile stress. Now, tensile stress is a phenomenon or is a stress that happens when two equal forces or loads are acted upon a beam. So, for example, there's a force drawing this beam in this way or the material in this direction. There's a force drawing this material in this direction. Now, it will result to an extension or elongation of the length of that material. So, in this case, let's call this a new elongation. So tensile stress is a phenomenon, is a stress that happens when two equal and opposite forces are acting on a material and it brings about an increase in the length of the material. That is what a tensile stress is. Number two, we have a compressive stress. Compressive stress. It is the opposite of the tensile stress. Now, in this case, we're having another material where two equal and opposite forces are acting in this direction. Now, before they were acting outward, pulling the body outward, pulling it outward. For a compressive stress is pulling the body in. Now, it will result to it a decrease or a shortening of the material. So take note, it is compressive stress when two equal opposite forces are acting, which they are pushing the body, and it will result to what? A decrease in the length of the material. So when there's an increase in length, it is tensile. When there's a decrease, is a compressive stress. Very, very important.